All right, what's up, Algebra 2? All right, so here we go. Second to last lesson, completing the square. All right. So, number one, we need to make the leading coefficient to be 1. Number two, make sure the constant, that's the non-variable term, is alone on the opposite side of the equal sign from the rest of the equation. And then number three, add the square of half of the coefficient of the linear term, that's the term with a variable which has a power of 1, and add that to both sides of the equation. All right, so I don't know if you've never seen these before, that's a lot to take in. So I'm going to go through step number one, okay? Make the leading term to have a coefficient of 1, okay? So here's our leading term. All right, this is the quadratic part, this is the quadratic term, this is the linear term, and this is the constant. Okay, so the quadratic has the power of 2, the linear has a power of 1, and then the constant is the term that does not have a variable. All right, so the first thing we need to do is we need to make this so it has a coefficient of 1. So we're going to divide by 3. But what I do to one term, I must do to every term. Okay? All right, so when I rewrite that, that gives me x squared plus 4/3 x minus 4. Okay, now, second step. Make sure that the constant or the non-variable term is alone on the opposite side of the equal sign. So that's this right here, so we're going to add 4 to both sides. Okay, so remember, I can't add 4 to this and this because they're not like terms. So I'm going to add 4 over here, add 4 over here. So that cancels that out. And now my equation looks like this. X squared plus 4/3 x equals 4. Okay, now we're going to take the square of half of the coefficient of the linear term. So that's this one right here. The coefficient of the variable that has a power of 1. Okay, so first of all, we need to take half of this. Well, what's 4/3 times 1/2 gives us 4/6. Okay, which actually reduces down to, if you can reduce it, then reduce it. That reduces down to 2/3. Okay. All right, so we're going to take 2/3, and now we're going to square it. So 2/3 times 2/3 gives us 4/9. Okay, so we're going to add 4/9 over here, and we're going to add 4/9 over here. All right, so this is going to give us 4 and 4/9. And a lot of times it's going to be easier to just make this into an improper fraction. So that's 36, that's 40/9. All right, now over here, this is going to be a lot easier to factor now. Okay, this would have been more trouble to factor up here, but so this is going to factor into x plus and x plus. We're going to factor out this trinomial right here. All right. Okay, so we need this the value that takes this place and this place when we multiply these together. Remember, when we do the FOIL method, need to give us 4/9. Okay, so that's going to be 2/3. Right? So 2/3 times 2/3 gives you 4/9. So now let's double check. So it gives us x squared plus 2/3 x plus 2/3 x plus 4/9. All right, so that gives us x squared plus 4/3 x plus 4/9. So that those check. That means that this is a correct factoring. Okay. All right. So now we've got just kind of a review here. Let's see what we've done so far. Okay. So we made sure that the leading coefficient was 1. That's why we divided everything by 3, so that we could get that, make that a 1. Okay. We brought our constant over to the opposite side. Okay, and that gave us 4 4/9, which we made into an improper fraction, 40/9. Okay. We took half of the coefficient of the middle term, and then we squared it. So half of 4/3 is 2/3. 2/3 times 2/3 gives us 4/9. And we add whatever the square of half of this middle term, we're going to add that to both sides. All right. Now we're going to factor out this trinomial right here. So that's what we did there. So we got x plus 2/3 times x plus 2/3 equals 40/9. Okay, so that's where we've stopped so far. Okay. Now, so basically what this is then is this is what you're going to end up having here is this is going to be x plus 2/3 squared equals 40/9. Okay. Because we have it being multiplied by itself. So it's squared. All right, so we're going to square root both sides here. And that's going to give us x plus 2/3. Remember when we square root something that's squared, basically it just removes that square right there. We're doing the inverse operation of squaring it, which is to square root it, right? Okay, so it just leaves us with x plus 2/3 equals, okay, so remember, this can be broken down, we can rewrite this as the square root of 40 over the square root of 9. All right, well what that gives us then is, okay, the square root of 40 is not a perfect square. So that stays the square root of 40. We'll come back and simplify that here. But then the square root of 9, that's a perfect square over 3. Okay? So now we've got x plus 2/3 equals the square root of 40 over 3. Okay? All right. So let's go ahead and simplify this radical right here. So the square root of 40, I'm just going to come up here for some workspace. All right, so we're looking for factors of 40 that are a perfect square. Can you think of any? Any factors of 40 that are a perfect square? Well, how about the square root of 4 times the square root of 10? That gives us the square root of 40. And the square root of 4 has a perfect square, which is 2. So we're going to pull a 2 out, and we're left with the square root of 10. Okay, now the square root of 10 does not have any factors that are perfect squares. The only factors of 10 are 1 and 10 and 2 and 5. None of them are perfect squares. So that is, the square root of 40 is actually reduced down to 2 times the square root of 10. So I'm going to rewrite everything I've got here. So I've got x plus 2/3 equals 2 times the square root of 10 over 3. Okay. All right. Now, if we're going to solve for x, we're going to subtract 2/3 here, subtract 2/3 here. we get x equals negative 2/3 plus 2 times the square root of 10 over 3. Okay, now these numerators here cannot be added together. All right, they can't be added together because they're not like terms. I can't take negative -2 plus 2 times the square root of 10. Just like I can't take 2 plus 2c. Okay, they're not like terms. Okay, so this actually ends up being the solution to that equation there. Okay. All right. So now you're going to see several in your lesson that are like this. It's going to say choose the constant term that completes the perfect square trinomial. All right. So again, we're just going to take half. Now I know I've said over and over again that we don't look at this like 18. We look at it like negative 18. But this is going to be one of those cases where we're only going to deal with the numerical value portion of the coefficient. We're not going to worry about the sign. All right, so we're going to take half of the coefficient of the linear term, which is 9, and we're going to square it. So that's 81. Okay, and that would be your answer. Okay, how about this one right here? So half of this, so that's 1/2 times 1/2 gives you 1/4. Now we're going to square 1/4. So 1/4 times 1/4 gives us 1/16. Okay, so we're taking half of it. Well, how do you take half of something? Well, you multiply it by 1/2. So 1/2 times 1/2 gives us 1/4. Then we're going to square 1/4. 1/4 times 1/4 is 1/16. So we're going to add 1/16, and that would be your answer right there. Okay, so they don't always end up kind of weird like this. This is kind of a strange looking solution to our problem here. Sometimes it ends up as a nice round figure. All right, but hopefully that'll be a help to you as you're going through the lesson. Okay, so just remember the steps. Make the leading coefficient to be 1. Make sure that the constant to the non-variable term is alone on the opposite side of the equal sign. Add the square of half of the coefficient to the linear term to both sides of the equation. Okay, then you're going, and what's going to happen, then you're going to, so that brings us to this stage right here. That's what we did right here. So we took half of this and we squared it, and which is 4/9, and we added 4/9 to both sides. We made this into an improper fraction. 4 4/9 gave us 40 over 9. Then we factored this out. Okay, and what you're going to end up with is a situation where it's going to be something squared. So x plus 2/3 times x plus 2/3. Well, that's x plus 2/3 squared. So we're going to get rid of that square by square rooting both sides. Okay, once you square it both sides, then you're just going to solve for x. Okay, so hopefully this will be a help to you. And God bless. Talk to you later. Have a great day.